In lesson 4.5, we're learning how to solve quadratics by completing the square. There's a list of steps at the top. So the first step is to move the c value to the other side. When you do this, leave a gap in between the linear term and the equal sign. Alright, so the next step is divide by a. But a is 1 for this problem, so dividing by 1 won't do anything. So then the step after that is we figure out what b is. B is 10. We take half of that, which is 5, and then we square that. So 10 divided by 2 is 5. And then we square that, which becomes 25. We're going to add 25 to both sides. The reason we do this, it creates what's called a perfect square trinomial on the left. So what that means is on the left it creates one of these. You need to figure out what goes in the right side of the parentheses. 11 plus 25 is 36. So if you think back, you started with b, you divided it by 2, and you got 5. The value before you squared it was 5. So whatever that value is will go here. That might be positive, that might be negative. So we took 10, divided by 2, and got 5. Then we squared 5 and got 25. The value before we squared it was 5, and that will always go in the right side of your parentheses. Alright, so now that we have something squared on the left, we can square root it to get rid of it. When you square root the right side, you have to put plus or minus in the front. Okay, the radical and the square cancel each other out. We're left with x plus 5 equals plus or minus 6. Then we subtract 5, and when we do that, we put it in front of the plus or minus. So negative 5 plus or minus 6, and that gives us two answers. Negative 5 minus 6 is negative 11. Negative 5 plus 6 is 1. Okay, moving on to number 2. We do the same thing. So first thing is move the c value to the other side, leaving a gap. Right, so for this one, b equals negative 6. We take half of that, which is negative 3, and then we square negative 3. So we're going to add 9 to both sides. And again, the reason we do that, it creates a perfect square trinomial on the left, which means it is factorable. X minus 3, because negative 3 was the value before we squared it, equals negative 16. To get rid of the square, we square root both sides. When you do this, you must put plus or minus on the right side. X minus 3 equals plus or minus 4i. So x equals 3 plus or minus 4i. Okay, number 3 is just slightly more difficult because there's an a value that is not 1. So it doesn't really matter if you move c first or if you divide by a first. So I'm going to go in the order that the notes lists it in. 2x squared plus 16x equals negative 44. Then I'm going to divide everything by a. X squared plus 8x equals negative 22. Right, so on this one, my b value, it used to be 16, but I'm not going by that. I'm going by the 8. My b value is now 8. So I take 8 divided by 2 is 4. 4 squared is 16. So now I'm going to add 16 to both sides. Okay. And now I have a perfect square trinomial on the left, which is factorable. Okay, what was the value before we squared it? It was 4. X plus 4 equals negative 6. X plus 4 squared equals negative 6. Square root both sides. Plus or minus on the right side. X plus 4 equals plus or minus. And anytime you take the square root of a negative, you can pull out an I. 6 is 3 times 2, so radical 6 will not break down. Okay, so now we move the plus 4 to the other side. And when you move it to the other side, it becomes negative 4. So negative 4 plus or minus I radical 6. Now we have a couple word problems. A rectangle has dimensions 6 centimeters and 5 centimeters. Let's draw that. If each dimension is increased by x, so I made the 5 longer by x, I made the 6 longer by x. So we know the old dimensions were 6 by 5, which has an area of 30. And then the new dimensions are x plus 5 times x plus 6. And we know that this area is tripled, so we take 30, multiply by 3. The new area should be 90. And we need to solve that. So let's FOIL. X squared plus 6x plus 5x plus 30 equals 90. X squared plus 11x plus 30 equals 90. X squared plus 11x minus 60 equals 0. And we don't have to use completing the square for this problem. It is factorable. Negative 60, positive 11, the two numbers that multiply to negative 60, but they add up to 11. If you're multiplying to a negative, you need a positive and a negative. So this one's going to be positive 15, negative 4. If you're not sure, write out all the ways to make 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15. That'll do it. So you can skip 5 and 12, and you can skip 6 and 10. Okay, the next step after that is we put it back into binomial form. Or you could use the shortcut I taught you. The answers are going to be the opposites of these numbers. So what would make this 0? And what would make that 0? By the zero product property, we know that if something times something equals 0, one of those has to be 0. So what would satisfy this if x were negative 15? What would satisfy that one if x were 4? Negatives don't work for this problem because we can't have a negative length. So now looking at the question, all they want is the value of x. So that is 4. When the dimensions of a cube are reduced by 2 inches on each side, the surface area of the new cube is 96 square inches. So first I'm going to draw a cube. A cube is a 3-dimensional prism. So it's like a square, but 3-dimensional. So every length has to be the same. So the length, the height, the width, they're all the same. So originally those were x. The length was x, the width was x, the height was x, but all of those were reduced by 2. Surface area is the area of every single face. So it would be the area of this side plus the area of this side plus the area of this side plus the other 3 areas that you can't see. So the surface area of this, well, one side would have a surface area of x minus 2, and there are 6 identical faces, so all of this would equal 96. Now, I don't want to have to deal with foiling out x minus 2, so I think I'm going to let y equal x minus 2. And so this is going to become 6 times y equals 96. 6y squared equals 96. Y squared equals 16. So y equals plus or minus 4. But in this case, the negative 4 doesn't make sense. So y equals 4. Now that's the new dimension. That's after it has been reduced by 2. So if x minus 2 equals 4, then the original dimension was 6. So our answer is 6 inches by 6 inches by 6 inches, since the question asks what were the dimensions of the original cube.